Types of inductors: air core, ferrite, magnetic or iron core type, toroidal core type, bobbin based inductors, multi-layer inductors, thin film inductors. So we will see in detail. Yeah, air core inductors. So here we see, we may have seen component like this in P series. Okay, so this is a completely inductor, right? So what we see here, this is coil, right? And within this coil, of course, there is going to be this particular gap. This is nothing but the air gap. So nothing is there. No metal or no ceramic or nothing is present. So this is a air gap, right? This component. So these are called air core inductor. Okay. Yeah, this is a very commonly used inductor, and it is simple winding, and there is nothing. There is air. This has nothing but air, right? The non-magnetic material like plastic and ceramic are also used as cores, right? Uh, and these are used in yeah, like high frequency applications where you have to generate high frequency signals. So the number of turns that are going to determine the inductors, right? The size is going to determine these inductors, right? The smaller the size, right? The number of turns and material that is used for designing this inductor is going to determine this inductor. Right? General range is up to 1 Henry or yeah, 1 millihenry or 3 millihenry. And even less range is possible up to 0.01 uh, millihenry or 0. Something 10 millihenry. Ferromagnetic or iron core type inductor. So you may have seen this structure, right? So this seems like a transport, right? Okay, and there is an iron core, right? And along this iron core, now within this iron core, this copper or copper winding is stuck, and some magnetic flux flows through this core. Okay, so this is a type of ferromagnetic material. Iron is a ferromagnetic material. Okay, so ferromagnetic material can be used along this iron core, right? Yeah. Ferromagnetic or iron core inductors have high inductance properties due to their higher magnetic permeability. These types of inductors are high power inductors, but incomplete in higher frequency capacity due to the current losses, namely AD and hysteresis. The best example of these types of inductors are transformers. Right? So these types of inductors cannot be used for higher frequency application. For that, we need uh, lower type of inductors, lower inductors, right? So ferrite core inductor. So what we see previously, there was a gap within this coil, right? Now we are placed here a ferrite core under this coil. So this coil, you can see that this coil is wrapped along a ferrite core. So this is a ferrite core inductor. And, the complete inductance is going to be dependent on this, the self inductance also, self induced EMF. Okay. So, yeah, these are the different types of inductors which offer advantages of decreased cost and low core losses at high frequencies. Ferrite is a metal oxide ceramic based on mixture of ferric oxide, okay, Fe2O3. Soft ferrites are used for the core construction to reduce the hysteresis loss. So this is high frequency uh, ferrite core inductor. It is used for high frequency applications, RF applications, intermediate frequency applications. Uh, yeah. Then toroidal inductors. So this has a shape like a toroid. This coil is yeah, this coil is maintained in toroidal fashion. along this circular toroidal core, right? So in toroidal core, inductors, a coil is wounded on toroid circular form. Okay. Flux leakage is very low in this type of inductor. However, special winding machines are required to design this type of inductors. Yeah. So sometimes ferrite cores is also used to decrease the losses in design. The ferrites can be used as a core for this inductor. These are also available in the range of 1 milli to 3 milli. Yeah. These can also be found in common applications like filters, okay, signaling, signal conditioning, okay, because of this good filtering properties. Okay, yeah. Then bobbin based inductor. So these are, yeah, what we see here. There is a bobbin type structure, and with the bobbin type structure, this coil is wound up, right? So yeah, bro. This type of design or this type of inductor can be used for certain voltage controlling applications like maybe higher voltages. We're controlling some higher voltages, right? So yeah, bobbin wound inductor designs vary widely in terms of power rating, voltage, and current levels, operating frequency, etc. These are most commonly used in switch mode power supply, right? So power conversion applications. These are some of the inductors. Then we have multi-layer inductors, cheap type inductors, assembly type, surfacing type. There are different layers. Can be arranged. Different layers of those electrodes can be arranged. So multi-layer inductors includes two conductive coil patterns which are set into layers. So this is a one layer. This is second layer. So likewise, we can increase the inductance, or we can because inductance can be manufactured with semiconductor devices or very small scale. We cannot include inductors in integrated circuits. We have to apply those coils or inductors external to the circuit. So, but still there are uh, some ICs, surface mount devices, with using semiconductors. We can manufacture this cheap type inductors or inductors in any ICs, integrated circuit. But what we have to do, we have to we should have a layered construction like this, layers of those coils, or layers of those coils arranged and connected to each other, right? We have at a particular term, and this is how miniature type of inductors we can design. Okay, the coils of these inductors are connected electrically in successive manner in series, or yeah, in series, right? You have two or more conductive coil patterns inclined in lower part of this multi-layered body. Yeah. So definitely, this is a very smaller miniature sized inductor, and so that's why it is used in applications such as mobile communication systems, right? Or for noise compression. Yeah. So this is the applications of this multi-layer inductor. Yeah, so this is the common structure, right? So this is the one of these structure, a cheap level structure, right? Where a coil is filtered on a particular plate, and similar coil will be again placed in along this vein. So this will be stacked together, and they will be connected in series, right? This is a multi-layer type, right? Okay. And yeah, these are the thin film inductors, right? This the length or the width of uh, this coil is very minute, micro level. So that is why the size becomes miniature. This type of inductors, yeah, minute inductors are shaped using thin film processing technology to make the cheap inductor for high frequency. So this frequency, so this inductance is very small, nanohenry. So when we uh, combine capacitors of this nanofarad with this nanohenry, so definitely the resultant product, that frequency range, you will get a very high frequency range, that is up to gigahertz and terahertz. So high frequency applications will require such components.